Hey, welcome to 9.2.3. We're going to do two chapters in one, which is graphing and solving quadratic functions. I'm trying to hold this up because otherwise it's a terrible angle. Let's see. Today's learning objective is that we are going to graph quadratic functions in the form of ax squared plus bx plus c. So last lesson we just graphed ax squared, and so today we're going to understand that b really affects the line of symmetry, and it affects kind of like where it's located. And then we're also going to solve quadratic function using both graphing and square roots. So kind of our key concept is that the graph is the graph of a quadratic function. So the graph of a quadratic function, so y equals ax squared plus bx plus c, where a is not 0, because if a is 0, then that means that there's nothing squared, and then we just have a linear function. Has the line that b divided, or negative b divided by 2x as its axis of symmetry. So the x coordinate of its vertex is that. So let's think about what that means in terms of like how, what if I put it down? That's better. Let's think about like kind of mathematically what that means. That means that like if I have this, parabola, and it's a very shaky one, and I've got this line of symmetry right here, I know that this x value of that point right there is whatever my b value is, the opposite of it, divided by 2 times the a value. Now, the other part that we're going to talk about today is wherever this line crosses our x values, these are the solutions. So if we can find what the vertex is, all we need to do is just point or plot a couple more points on either side so that we can figure out what our parabola looks like. So if we consider these following graphs, I have 2x squared plus 2x. I have 2x squared plus 4x, and I have 2x squared plus 6x. What are you noticing about the graphs? They're about the same distance wide, so they're not changing in their distance wide, because what changes the distance width is your a value. So your a value changes how wide it is, but your b value is really telling us where is that crossing the x-axis. So our b value is telling us how far down the y-axis are we going. I'm sorry, I'm getting myself readjusted here. How far down that y-axis are we going? And notice that the bigger the y-axis, the bigger the b value, the further down the y-axis it's going. So notice our axis of symmetry changes within each one of these b values. The equation of the axis of symmetry is related to that ratio of b divided by a. So in this first one, if I take the opposite of 2 and divide it by 2 times 2, we get 1/2. So we get that negative 1/2, so that's why it's down there. But if I take this second one, I keep forgetting that if I take this second one here and I take the opposite of b, which is 4, and divide it by 2 times a, which is 2 times 2, I end up with negative 4 divided by 4, which gets us that negative 1. So at negative 1, that's where my line of symmetry is. So it's changing that. So the bigger this b value, the further out it goes and the further down it goes. And we're going to talk about that a little bit more. So when we're graphing quadratic functions, in our last unit or last lesson, we talked about making a table and then you just plot the numbers. That's fine, that works, but it's also very tedious. It takes a long time. So if we know the axis of symmetry and understand that the basic shape of our quadratic function, is it a smiley face or is it a frowny face? You can mark the axis of symmetry and then just use 1 or 2 points to help you graph. So how we're going to do that is we're going to find the axis of symmetry, and then we're going to plug that in for the vertex. And I'll explain that in a second, because we're going to find, when you find the axis of symmetry, you're finding your x value. So if we plug in our x value, we'll find our y value. So that's going to give us not only our axis of symmetry, but our vertex. Where is it crossing? And then we're going to find the y-intercept. We're going to, by doing the x as 0, and then we just find another point. And then we remember that there's that fold line, so then we just copy it onto the other side. So find our axis of symmetry, plug it in for the vertex, find our y-intercept, what happens when x is 0, and then find our other point. So here we go. What is the graph of the function? So the first thing I'm going to do is I am going to try to write, we'll see what happens. We're going to use the axis of symmetry line, so that opposite of b, and b is -6, so the opposite of -6 is 6 divided by 2 times 1. So that's x is 6 divided by 3, or 2, which is 3. Okay. So if I know x is 3, I know that somewhere on this line right here is going to be my fold line, or my axis of symmetry line. But if I go in and plug 3 in, I'm actually going to find the coordinate that is my vertex. So it might be a positive or a negative. We'll talk about that in a second. So I'm going to go ahead and plug in this 3 into this and this. And we're going to get 3 squared minus 6 times 3. Ooh, this is terrible. Plus 4. Okay, so we get 3 squared. So 3 times 3 is 9. Minus 6 times 3 is 18. Plus 4. So 9 minus 18 is -9. Plus 4 is 5. -5. Yikes, look at that handwriting. Okay, so we get this -5. So I know that at x is 3, y is -5, 3, 1, 2, 3, 4, 5. That's where my vertex is. Now, go look at your a value. So remember your a value is right here. Do I have a positive or a negative a value? I have a positive. So that means that my parabola is going to look something like this. It's a smile. Smiles are positive. Brownies are negative. We don't want negatives. Brownies, brownies, brownies. So I know that this is a negative, so that's what my parabola is going to look like. Now, we need to go back, and it says find our y-intercept. So what happens when x is 0? So we're going to plug in a 0 for both of these. If I plug in a 0 to both here and here, I end up with just plus 4. Because 0 squared is 0 minus 0 is plus 4. So when x equals 0, y equals 4. So at 0, 4, excuse me, 0, 4, I have 1, 2, 3, 4. Okay. Now, I know that the axis line of symmetry means that I can fold this over this line here, and it's going to be the exact same on the other side. So I can, if my axis of symmetry is kind of right here, I can just go over the same amount and just know that I'm going 1, 2, 3. Hold on a second. What did I do? That point is in the wrong spot. 0, 4. You're probably like, Miss Sevelius, what are you doing? Okay. Okay, so if I start at my center and go up to 4, 1, 2, 3, 4. How about that? How about that? Okay, now if I go over this line of symmetry, I'm going to go over the exact same amount. So I'm going to count to my line of symmetry. 1, 2, 3, and then go over the same amount. 1, 2, 3, and I'm going to put another point right there. Okay. So now I've got these 2 points. Now you might be able to make a pretty nice parabola. 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 And to be honest with you, I would probably be okay with that. However, sometimes we get really shallow parabolas. And remember, shallow parabolas are made because we have a fraction for an a value. And if you get a really shallow one, you sometimes need a second point to kind of figure out where you're going so it doesn't just look like a straight line. But that's about it. So now what we're going to do is you're going to try it and you're going to do the same thing, but you have a negative. So what we know about that negative is that it's going to be a frowny face. So go ahead and pause it, come back and check your work.
Okay, so when I did this,
I went through and I used the line of symmetry formula to find that my line of symmetry was 2. And then I plugged 2 into the equation to get a vertex of 2, 2. Then I went and I found my y-intercept by plugging 0 in and found that when I put 0 in, my y value is -2. So I have a point here at -2 and 0. And then I just copied it and then moved on. So let's kind of move on. And I don't know what happened to my picture again. I'm sorry. It's gone. So now what we're going to do is we're going to solve quadratic functions. So a quadratic equation can have 2, 1, or no real number solutions. In a future course, not my course, you're going to learn about solutions of quads that are not real numbers, but I'm not ready for that. So in this lesson, solutions refer to the real numbers, and generally it's going to have 2 or 1 solution. Solutions in quadratics are also called the roots of the equation or the zeros of the function. I have zero idea of why the same idea has 3 names, but it does. So let's look at the following graphs. This graph right here shows a graph where we have 2 solutions. And the 2 solutions are basically the x-axis intercepts. And you can... Excuse me. This graph has 2 of them, where this graph only has 1. This example right here is a graph that has no solution, and this is the type of graph that you will be doing at a later time. We are going to be looking at these 2. So if we're looking for their solutions, and I particularly look at this one right here, all I have to do is name the 2 points. So this particular point is located at +1, 0. We're not going up anywhere. So when I write that out, I have +1, 0. And then this particular point right here is at -1, 0. So we write that as ±1. That's the solution for A. Now B just has 1 point, and it's the origin. So our 1 point is our solution, and it's 0, 0. So what we're going to do now is we are going to graph this in whichever way you want, and we're going to look for those 2 solution points. I'm going to make a quick table. This is a pretty simple equation, so I'm just going to make a quick table and go ahead and plug these values in for this x. So if I plug a -2 in for this x, I have -2 times -2, which is +4. 3 times +4 is 12, plus 6 is 18. I'm going to do the same thing with -1. So -1 squared is +1. 3 times 1 is 3, plus 6 is 9. And you might be asking me, well, why are you putting these ones in? Well, I'm putting those ones in because a negative times a negative is a positive, and a positive times a positive is a positive. So it doesn't change its value just because it's negative. Lastly, I'm going to put the 0 in for the x. 0 squared is 0. 3 times 0 is 0. So 0 plus 6 is 6. Now I'm going to go in and graph these points. So at 0, 6, I'm going to my origin of 0 and up 6. Then I'm going to go to -1 and go up to 9. And then I'm going to copy its opposite on the other side. Now -2 at 18 and +2 at 18, I can't graph. So I'm just going to make my parabola based off of these 3. Now, I'm going to ask myself, does this have a solution? It does not. So this is a no solution. we're going to do another way of solving solutions by finding the square root. As you know, an equation is basically a scale. And what's on this plate has to equal this plate. That's what this equal sign means, is that what's on this side is the same as what's on this side. What's on this side is the same as what's on this side. So as I go through and do this, oops, I thought that was the eraser. As I go through and do this, we're going to need to keep that idea of inverse operations in our heads. I'm going to draw a line because drawing the line makes the most sense to me. And I need to make it so that I'm solving for x. So if I need to get x by itself, I have to get rid of everything else but the x. Remember, this is your door. You're having a party, and everyone is invited except for your x. So I'm going to add 75. Now, you might notice that I split up these two terms. These are two different terms, and I split it up because I need to get rid of that 3. So instead of multiplying by 3, I'm going to divide by 3. In which case I get x squared equals 25. Now I need to ask myself, well, what's the square root of 25? Because remember, the opposite of squaring something is finding its square root. So the square root of 25 is 5. But I also have to remember that it is also negative 5. Because negative 5 times negative 5 is also positive 25. The way that we write this is then plus or minus 5. Let's do one more. This time, it's changed just a little bit in that I have a number other than 0 right here. But honestly, I'm just going to add the 16 to get 32 and 4d squared. Now, just because I have this d here doesn't change the fact that I still need to get the d by itself and then find the square root. So the first thing I'm going to do is I'm going to divide by 4. Now I get d squared equals 8. Now, we don't know what the square root of 8 is. But what I do know about 8 is 8 has 2 factors. One is 2 and one is 4. Both of these have a square root. This one for sure. So when I square these, what I end up with is d equals plus or minus 2 times the square root of 2. And I know this because if I take the 2 square roots, the square root of 4 is 2, and we don't know what the square root of 2 is. So that ends up right there. Again, our final answer becomes d because the square root of d squared is d. And the square root of 8 is 2 times 4, square rooting both. I can find and simplify this, but I cannot simplify this. It's plus or minus because if I subtract or multiply 2 negative numbers, they become positive. I'd like for you to give these two a try. Come back and check your work. All right. So when I did this first one, I added 8. I got 2x squared equals 8. Divided by 2, I got x squared equals 4. I found the square root. X equals plus or minus 2. When I did the second one, I added 36 to 64 and got w squared equals 100. When I found the square root, I ended up with w equals plus or minus 10. If you got that, great, let's move on. If not, pause it and make sure you understand. Basically, our big concept today is that quadratic functions have 2, 1, or 0 x-intercepts. And those are the solutions. If a quadratic function does not have any zeros, the answer is no solution. Don't forget your practice work on Math Excel. And if you have any questions, remember I'm on Zoom all day. Hope you have a great day.